So welcome back students to the second video of your metals and non-metals. So here the most important topic, that is physical properties of metals and non-metals. Ma'am, what are physical properties? Okay, I'll explain that. Suppose let us assume you're so-and-so XYZ. I ask you what are the physical features. So somebody, my friend explains me, okay, who is that Mr. Ravi means? Okay, Mr. Ravi is so-and-so. He is 6 feet tall, fair in complexion or whitish in complexion. He has brown eyes or gray eyes, or they'll be explaining you all the physical characters of that. Like that only for metals and non-metals also we will see whether it is hard, whether it is soft, whether it is soluble. If I take the metal, will it conduct electricity, or what can I draw it into wires, or is it soluble? Like that, different physical properties we'll see, right? Density, right? So important, as I said, take out your book and write the heading physical properties of metals and non-metals. Little bit long lecture, let us enjoy and learn. So whenever I have to speak about metals, the first important thing, both together I'll be explaining, right? So metals have, or if I have to speak, they have a property called malleability. What is that? Malleability. Okay, so I'll not write every time metals, I'll just write they are malleable. So I'll just write malleability. So if I have to say metals are malleable, so I'll underline that, right? So I'm not writing full sentence. Now what is malleable? Malleable is nothing but it is property of metals to be drawn into sheets. Means I can take the metals and I can draw into, I can extend or stretch it into long sheets. Sheets, if you see the word, it means it is nothing but malleable. If I have to speak about non-metals, the important, the first thing, non-metals are, they should not write. Non-metals are non-malleable, means they are soft in nature. I can't draw them in sheets. So here non-malleable means non-metals cannot be, I'll write the full sentence, non-metals cannot be drawn into sheets. This is over, right? Now if I have to speak about the important example, if in the metals I have listed a lot, I have explained you in the previous video also. In the exam they're going to ask you, among all the metals, the first metal which is more or which can be drawn is, or which is malleable. If they ask you, I can say silver and gold is one which they can be malleable. I can make it into thin sheet also. As I have drawn 1 gram of gold can be, you can make a wire of 2 kilometers long itself. That is ductile property. So as I said, silver and gold, they can be made into sheets. This is the first most malleable metal. So this is the most. After this comes the next category of metals, that is aluminium sheets, copper sheets, and also iron sheets. So these all can be drawn into sheets. Ma'am, there are others also, but here this is given the first criteria for showing the malleable property. So if they ask you what is the most malleable metal, you can say silver and gold. What is the next most malleable metal? Aluminium, copper and iron. Now let us come to non-metals. So in non-metals, I said they are not malleable, they are very delicate. So what is the opposite of non-malleable? Nothing but brittle. They are going to break. Suppose if you are trying to take the hammer and see, if it is a metal, if I start hitting it, it will start stretching. But if you start hitting a non-metal, it will start breaking into pieces. Brittle means it will break into pieces. In the non-metals, the most brittle, or this one is sulfur. Next comes carbon. Next comes phosphorus. So sulfur, I am writing the symbols. Okay, let us write full form. Sulfur is the most brittle, yellow color, it is very soft it is. Next comes carbon. Next comes phosphorus. So in carbon, what is it? Carbon in the form of graphite. If it is graphite, it is very soft. If I start beating, if I use some pressure, it will immediately break into pieces. Nothing but your pencil lead, no? Pencil lead, if you are sharpening after some time, it will also start becoming powder, soft powder. So in the form of graphite. So you need to remember these exceptions. This is where they're going to ask. Most malleable, which is most brittle. Now let us come and learn the next property, that is nothing but the ductile nature of the metals and non-ductile nature of non-metals. Right, now the next property of the metals, physical property of metals, that is metals are ductile in nature. So here non-metals are non-ductile in nature. Right, let us see what is ductile means. So what did we learn? Malleable means they can be drawn into sheets. Opposite, simply just like that, it is the property of metals to be drawn into wires. So there we have written sheets, here we are written wires. So remember, ductility means drawing into wires. When it comes to non-metals, I told you, isn't it, they're soft in nature. So non-metals cannot be drawn into wires, so they are non-ductile. So here you can write non-metals are, or non-metals do not show ductile property. Why? Ductile property because they are soft. They are soft in nature. Simple, isn't it? I can justify my word. Now, in the exam, what they're going to ask you? Remember, in the exam, they're going to ask you the most ductile metal. That is what is the question. So please note the definition. I'll write that. So I think you have noted. Right. So if I have to take the examples of the most ductile metal in the exam asked, so among all, gold is the most ductile metal. So this is getting the first prize. As we said, I can take 1 gram gold and I can stretch it into wire of 2 kilometers. Till 2 kilometers I can stretch that 1 gram gold into thin wire, it seems. After that, this is the most, let us write most ductile metal. After this comes your aluminium. Next comes copper. Aluminium wires, copper wires. So I can write that. After aluminium and copper, you have iron also, thin, because iron scrapings we take, no? Right. Then you have tungsten. Where are we using tungsten? Okay, let us write magnesium also. Magnesium also is there, tungsten. So iron, as we said, iron scrapings. Magnesium, I use it in the form of a wire gauge or magnesium ribbon in the lab. After that, even the wire gauge also, thin wire gauge in the lab also, magnesium is used. Tungsten is used in the bulbs, isn't it? So thin wire of filament which is there in the bulb is made up of tungsten. So in the exam, they'll ask you the most ductile metal, gold. The next most, aluminium, copper. Next comes iron scrapings. I'm talking about iron scrapings. And next comes magnesium and tungsten. So iron is there in the malleable property and ductile property also. Here non-ductile, we said non-metals cannot be drawn into wires because they are soft in nature. That's why I have not given any examples. Now let us come back and do the next property of metals and non-metals. Right, so next comes the third property of the metals and non-metals. Let us write that. Metals are good conductors of heat. First we will write in terms of heat. Conductors of heat. That means, okay, let us write the heading and then come. And non-metals. NM is non-metals are bad conductors of heat. There are few exceptions, I'll do that also. bad conductors of heat and electricity. Also I'm writing here, heat and electricity. So here when I have to speak, first of all, what actually is conductor? That means suppose you're taking a metal rod, okay, you're holding one metal rod, you're putting it in the fire. So what happens, after some time, to some extent you can hold the metal rod. After some time you start feeling that hotness in your hand and you'll throw the metal rod down. What is happening in this process? In this process there is flow of electrons from one end. Suppose this is a metal rod, you're burning this end and you're holding your hand like this. During this process the electrons flow from one end to the other. So because of this flow of electrons, you immediately feel that hotness in your hand and leak. So this flow of current or electrons from one to the other is called conduction. So here there is conduction of heat because of what? Free electrons. Now that is a concept. Metals are good conductors of heat, means there is supply of heat because of what? Because of free electrons. This is the concept. But in non-metals what is happening? There are no free electrons in non-metals. So because there are no free electrons, they do not conduct electricity, so heat and electricity. If someone asks you why non-metals do not conduct electricity or heat, you should say there are no free electrons in them, right? Right. So next important thing, in the exam, I think you have noted it, in the exam they are going to ask you three important examples. The first one, which is the best conductor of heat, best conductor of heat. They are going to ask you which is the good conductor of heat, which is the poor conductor of heat. You need to know the examples, right? And which is the exception also. They are going to ask you certain exceptions in non-metals. Let us write that and come back. When it comes to the best conductor of heat, I'm talking about heat. Remember, silver is the best conductor of heat. When it comes to the good conductor of heat, if I have to speak, aluminium is 1, copper is 1. Next important, which is a poor conductor of heat, means lead. Lead symbol is Pb. So this, remember, you need to write this examples. Silver, best. Next comes good. Next comes poor. Don't get confused. They may give you in the form of an MCQ or the fill in the blank. Now, when it comes to the bad conductors of heat and electricity, there are few exceptions like graphite. Graphite conducts electricity because of the fourth electron or the free valency which is there. So graphite is one. Graphite conducts electricity. So this is one exception. So I'll write it as in the red pen, exception. EXE, right students? So remember, they may ask you which is a non-metal which conducts electricity, nothing but graphite. From where it is formed? From carbon. So basically carbon exists in one form, that is graphite. It exists in the form of diamond. It exists in the form of fullerenes, Buckminster fullerenes. So in that, graphite is one. Because of 1/4 free valence electron, it starts conducting electricity. So I think you have noted this. Now we'll come and do the next property. Right, when we come to the next property, that is metals are, we have studied metals are good conductors of heat, earlier one. Now we are talking metals are good conductors of electricity. As they are free electrons, they allow the passage of current also. So again in the exam, what are they going to ask you? They are going to ask you what is the best conductor of electricity. I have given the example. Good conductor of electricity, aluminum and copper. But they will ask you what is the metal which has lower conductivity, that you need to remember. So among the metals which has lower conductivity or poor conductivity because they offer resistance, that is nothing but iron and mercury. This is one example you need to remember. Because again, as you have seen, on the surface of the wires there is PVC coating, polyvinyl coating, it will not allow you to get that shock. So because it is an insulator, right? It's made up of plastic, right? Yeah. So here these are three things which you need to remember. This is best, this is good, this is poor or lower conductivity. because they offer resistance. Now when it comes to electricity, that is non-metals we speak, remember we have said non-metals because they have no free electrons, they will not conduct heat and electricity, but one exception is graphite will conduct electricity, and it behaves like a metal also will conduct, graphite also will conduct electricity. Why I said? Because of free electron present in that, right? Now let us come and do the next property. So till now what did we learn? We have said about malleable property, we have spoken about ductile property, we spoke about good conductors of heat, we spoke about good conductors of electricity with examples. Next I'll be teaching about next few physical properties of metals and non-metals. Right, the next property, after studying all the four, let us write that. The fifth property is metals are lustrous in nature. They have lustrous or shiny surface. Shiny surface. Okay, right. So here when I have to speak about non-metals, as I said, they have dull surface. They are non-lustrous or they have dull surface. Now if I have to ask non-lustrous or dull surface, now again same thing, why they are lustrous? I said they have free electrons. So what will happen when light falls on the metal? Immediately, suppose this is a metal, I think if you take this, now in this metal there are a lot of electrons. So when sunlight falls on this, okay, the electron from the ground state, means it is there at the lower energy level, it will get excited to the higher state. Again it will fall down to the ground state. During this time it will, it will absorb that frequency light and it will emit or it will become bright. I think it is confusing you, don't worry, nothing. Why metals are lustrous? Because of free electrons. They keep exciting, going up down and they show that shine. So here why they are lustrous? Okay, lustrous or shiny surface means because of free electrons. Now non-metals, what did we say? No, they are dull because no free electrons. Done. Now again, if they ask you what is the most lustrous metal or which has more reflecting surface, you need to remember among all metals, silver and gold are the most bright or the reflecting surfaces. So they have silver and gold are the most bright or shining surfaces. Important. What happens is in most of the metals, after some time, as you've seen, silver also or even copper also, if you keep it outside, they'll get, they'll become dull surface. What happens on the surface of the metal? There is deposition of carbonates, right? On the there's a layer of oxide forming because of the oxygen, and what you can do is you can rub it with a sandpaper and automatically the lustrous surface comes out. So what is the question here? They'll ask you, why does metal appear dull? So you should say because of oxidation or because of the formation of an oxide layer, carbonate layer, they form dull. How can we remove this? By using a sandpaper. Correct. Now in non-metals, what is the exception which you should remember? So I think you have noted most lustrous metals. Done. Next, here there are few. Copper also is there which is shining. Aluminium also is there which is shining. But this is the best lustrous or best reflecting surface. Here when I have to speak about the exception in non-metals, remember exception is where they're going to ask you. I think the ink is not there. Okay, I'll write it with this black pen. When I take the exception, among non-metals, iodine is the only non-metal which is lustrous in nature. Remember, so they'll ask you this question only. Among the metals, silver and gold is a lustrous metal. Among the non-metals, iodine is the non-metal. It is the only non-metal which is lustrous like metal. Don't get confused. Study slowly, understand the examples and keep writing it. Now let us come and do the next property. Right, let us see the next, that is the sixth property of the metals and non-metals. So till now let us recollect: malleable, ductile, lustrous, good conductors of heat and good conductors of electricity. Now, metals are hard in nature. So let us write metals are hard in nature, right? Next thing, non-metals are not strong. So here the examiner will ask you the property, like that's simple, but what is important here is among the metals also you have soft metals, you have hard metals. Among the non-metals also you have soft non-metal and hard non-metal. That you need to remember the examples. So when it comes to the soft metals, lithium, sodium, potassium are soft metals. So what happens? I can take them and I can use a knife and easily cut it. Very soft they will be. So these are called alkali metals. So remember, what are the alkali metals which are soft in nature, which you can cut with a knife? You can take, it will be just like a soap only. Nice and soft it will be, you can cut it, right? So they are lithium. This is capital L, students, Li, lithium, sodium and potassium. Okay. Now, if they ask you what are the hard metals, simple. Iron is a hard metal, aluminium is a hard metal, copper is a hard metal. You can't cut it with a knife. Simply with knife you take and no. So this is where the examiner is going to ask. Now, why they are hard in nature? Simple. In the metals, there is a bond where one electron is like one atom is linked to the other, tightly packed. There's something called metallic bond. So because of the metallic bond, they're very hard in nature. Okay. So when it comes to non-metals, the soft non-metal which we have is nothing but graphite. So graphite is a form of carbon, isn't it? So graphite is an example of soft non-metal. Next comes hardest non-metal is nothing but diamond, right? So here both are forms of carbon only. So in carbon it shows, as I told you, graphite is one form which is soft, diamond is one form which is hard in nature. So the hardness, as I said, metallic bond exists in metals, non-metallic bond exists in non-metals. So please note the examples. Once again, if they ask you poorest conductor of heat, you should be able to say what is a which is the best metal which can be drawn into wires, you should be able to say. If they ask you which is the softest non-metal, you should be able to say.